Okay, so let's do the dihybrid cross that is in the lab manual. So in this case, we are looking at Drosophila, which is basically your typical fruit fly that is in your kitchen. Gray body color is dominant to ebony body color, while long wings are dominant to vestigial wings. Vestigial wings are short and stubby wings that have not developed completely. So answer the following questions for the mother who is gray-bodied and long wing, and the father who is ebony-bodied with vestigial wings. Assume both parents are homozygous for both traits. Okay, so in this case, you need to define the different alleles because they don't mention what they are. Let's do G. Let's see. Let's write it down here. Okay, so G will be gray. Let's see, gray body. Little g will be ebony body. And then vestigial wings, V, it looks the same as little b. Short wings, no, those are the same too. Let's just do wings. Okay, N, big N will be normal. Wait, body color, long. And then little n will be vestigial. Okay, so now that we have that resolved, and the questions will be easy. We're assuming a key piece of information is that we're assuming that it's homozygous for both, okay? So what is the genotype and the phenotype of the father? The father is ebony-bodied with vestigial wings, so this individual is going to be little g, little n. And what's the phenotype is going to be ebony vestigial. And the genotype and the phenotype of the mother is going to be big G, big N. And this will be gray long. What are the potential gametes produced by the father? So let's look at the father. He is homozygous, so he's only going to produce one combination, is little g and little n. Okay. And what are the potential gametes produced by the mother? And she is also a homozygous, so those are the only egg and sperm they're going to produce. What is the genotype and the phenotype of all the F1 offspring? Well, this is the egg and this is the sperm, the only thing you're going to produce is big G, big N, little n. That's it. And the phenotype, they're all going to be gray long. Okay. Now select the genotype below that are possible for the gamete in this cross, assuming meiosis occurs correctly. Now, we're talking about gametes, which means there's only going to be one copy of each gene. So here there's 3, so this isn't possible. This one, yeah, it could be. They're doing L for long here. This one, they're the same gene, so that's not possible either. This one, what is going on here? This one, no. Because there's only going to be one of each. They designated L for long, but we did N. Do we see a GN, a big G, big N? Yeah, this one. Okay, so this is the only one that's possible. The rest of them either don't have the appropriate number of alleles or genes or number of chromosomes in that particular cross, or they have one for the same trait and not for both. Okay. Answer the following questions of cross between a male and a female fruit fly that are F1 offspring from the previous question. Okay, so the F1 offspring, recall that all the F1 offspring have this genotype, okay? So we're going to bring this one over. So the genotype and phenotype of the father is going to be big G, little g, big N, little n, and then the same for the mother. And recall this, we just got it from here. Just got it from this question here. Okay. What are the potential gametes produced by the father? Okay, so at this point we need to FOIL. So let's FOIL these guys. So we have big G, big N, little n. This compare with this compare with this compare with this, and this compare with this. So we have big G, big N, here and here. Then here and here, big G, little n, little g, big N, and little g, little n. Okay. Now, since they're both the same, they're going to have the same number. And there's 4 unique, so then you draw your thing, but in this case, I gave it to you. So this will be big G, big N, big G, little n, little g, big N, and little g, little n. And the same over here. And then you're going to do your cross. You're going to complete, you're going to simulate fertilization. All I'm doing is pulling these, so big G, and then big N, little n. Okay. Now, what's the predicted phenotype of this particular cross described? What I would do is, these are 2 dihybrids, is write down all the different combinations starting with the parental. And so the parental is going to be gray long. And then the next would be, just stick with 1. So gray, maybe vestigial. And then ebony long. So do you see how these each carry a dominant trait? So this is dominant, this is dominant. And then finally ebony vestigial. Anything that has a big G and a big N is going to be, anything with a big G and a big N is going to be gray and long. Anything with a big G and then a little n is going to be gray vestigial. Anything that's little g, and then a big N is going to be ebony long. And then finally, the only one that's little g, little n is going to be ebony. Okay. So let's do this. Okay, so we'll start with yellow highlighter. So this one has a big G and a big N, big G, big N, big G, big N, big G, big N. La la la. Well, she can get it because we're going to see her in an hour, okay? Hey, Richie, I'm recording right now, please, okay? I'm almost done. So close. She'll come. We're going to see her later. Thank you. So 9. 3. So little g, big N here. Orange. This will be 3. And then finally, By the way, colored pencils work amazing as highlighters, just in case you want like an all one-size-fits-all type of tool to have in your bag. Okay, so that is that. So you're going to see the 9 to 3 to 3 to 1 ratio. Yay! Oh, I forgot to write here what the potential gametes of the father is going to be. Big G, big N, which is down here. And the same. Okay. And that is that. Yay. Okay, great. Thank you.